Yeah, we're live. It is 12:47 in the PM, I guess. Yeah, we're past noon, so it definitely is PM. Today we want to talk about welcome to the live feed where we get together, talk about some sort of subject matter for a little bit, 10, 15 minutes or whatever, and then open it up for discussion for question and answer. So if you're here and you're going to want to take a look at something, you got questions about your stuff, come here and join us. You know, there's lots of sharp guys here, and we can usually get your questions answered. If you got a project car or motor that you have questions about, this is the place to be. So today we're going to talk about, I have up on the thumbnail, basically it's a supercharged 496 AFR headed big block stroker that we put together with an 871. I think that was a Wyand blower that we did. You know, your typical kind of thing. Good heads on it. It had a roller cam. I'm sure it probably had the BR300 comp cam that I use and everything. And it had the blower on there with dual twin hollies on it and stuff, you know, kind of the way that you would do it. And the discussion today is about what cylinder heads should we put on that, or what cylinder heads should we put on a turbo application? What cylinder heads should we put on an NA application? Because I get a lot of comments from guys that are talking about, oh yeah, these are good, these make good blower heads, or these make good turbo heads, or they yada 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 yada. And so I want to dispel some of the myths about that, and who knows, maybe create more myths about it. But the question is there, you know, are there cylinder heads that are better for supercharged applications? We'll start there and then we'll go with turbo stuff and we can go with nitrous stuff. And there are specific things that we would want to look for in them, but it's not normally what people think. A lot of times they will, you know, and they do the same thing with camshafts is they'll go down the road of, hey, I got to look at the intake to exhaust flow relationship, and I want some sort of, and I've heard it go both ways. Okay, we want them to be even, we want them to flow the same, we want them to be skewed, and then we can alter that with camshaft. Well, with a blower motor, you need to get all that exhaust out, so we need to put a bigger exhaust valve and improve the exhaust flow. In fact, I've had people tell me, well, I want you just to port the exhaust side to get all the exhaust out. And honestly, when it comes to making power from NA stuff, nobody I know, not at any sort of professional level of engine building, if they were to be concerned with one or the other of those things on the cylinder heads, you'd be concerned with the airflow on the intake side, not on the exhaust side. Look at Pro Stock; they do everything that they can to get more air in, and then the exhaust will get out. I'm not saying that you shouldn't port the exhaust, and that exhaust flow isn't important. It is, but some people tend to favor one or the other, and honestly, for this channel and for me in particular, I don't favor either one of them. I think you should look at both. And I think that if you port something and you make them both better, the head's going to be better. It's going to flow more on both sides and it's going to make more power. I in the testing that I do, I don't normally choose a camshaft based on the cylinder head flow. I know a lot of guys look at the exhaust flow relationship and they decide, well, then I need this kind of camshaft with this intake and this exhaust and this much of a split, and that's all fine. And a lot of those guys will also use it. Well, the head flows up to this valve lift, so I need to run this kind of valve lift camshaft. And again, that's not how I pick my stuff. And if you look at any of the testing that I've done where we've put things together that have made good power, I like to show what things do. And I would, you know, sometimes go out of my way to demonstrate the flaws in those kinds of like thought processes, especially as an absolute. If somebody tells you, hey, look, your intake to exhaust flow relationship is only 78%, so you need to run this kind of camshaft, I would steer them to dyno data that shows otherwise. Because what happens if you don't run that kind of camshaft in there? And if you do run that kind of camshaft in there, does that camshaft, because of the split it has with that cylinder head, make more power than another one that doesn't? No, because if it made more power, it probably is a more powerful camshaft and would also make more power on a cylinder head that didn't have that intake to exhaust flow split. Same thing with superchargers, and that's kind of what we want to talk about. Is sometimes people attribute specific variables on cylinder heads to, oh, this is a good head for boost. So let's talk about that for a second. And the thing, in my opinion, that makes a good cylinder head for boost is the same thing that I look at for a camshaft or an intake manifold. How does it do NA? Is it an effective cylinder head? Does it make good power? If we take a 5-liter Ford, for instance, Is that cylinder head good for boost? Yes, you can run boost with a stock E7TE cylinder head. Is there a better head for boost? Well, yes and no. There's just a better head. There's lots of better cylinder heads, lots of cylinder heads that will make more power than the stock head. There's not one specifically that I would pick because I was running boost. I would just pick a better cylinder head than that one. And then the other things that would help you dictate what cylinder head you're going to pick. The number one for most people, far and away, for the vast majority of people, it's going to be price. I mean, price would be way more than how it does and what the intake to exhaust flow relationship is and whether I'm running boost and how big of a header I'm running and all these other considerations. People are not going to pick it based on that. They're going to pick it based on, I want as much power as I can have, and I want it as cheaply as possible. And so there's going to be some kind of mix in there between those two. The other thing to consider for cylinder head choice, whether it's a big block or a Ford or Chevy, whatever it is also I would look at what sort of static compression I want. So what is the chamber size? What are the available chamber sizes? I mean, if you're building a motor from scratch, then you can make everything be however you want. You can have this piston, dome or dish or flat top design combined with whatever this chamber size is, and you can make all of that fit. And you can go, I want this static compression, and here's how I'm going to achieve it. If it's something that you already have, let's say you already have a short block, and you're going to put a set of cylinder heads on it, well, then the cylinder heads you're going to put on there, whatever the resulting static compression ratio, might be a big consideration. If you're looking and choosing between 2 or 3 different heads, let's say that you've already taken price into consideration, and you're looking at these different heads, you might think, well, this one flows a little bit more, this one doesn't. I don't know what that's going to do. More likely than not, if we're looking at big block Chevy heads, they have the ability to support more power than you're probably going to make unless you're going all in on something. But if you were doing that, you wouldn't be putting a cylinder head on a stock short block or something. But you would want to look at what static compression ratios, what chamber sizes are those heads available in. Maybe one of them is 122 and the other one they have that's 110. If I put 110 on here, I'm going to add a full point of compression. That alone is going to add more power. It's going to get better mileage, although if you're driving a big block, probably mileage isn't too high of a consideration. But all of those kinds of things are important. And then what is the chamber size? What are the valve sizes? Will that fit with my bore size? You know, do I need to unshroud the valves, or is it all of that way too big already for my bore size? There are a lot of bigger considerations. Is it enough? Is it, you know, if you're looking at cylinder heads and you have a junkyard Gen 6 454 and you're choosing between cylinder heads that flow, I've got some that flow 370 CFM and some of them that flow 384 CFM. There's no choice there. Unless you're trying, you're not going to make everything that those cylinder heads will support with your otherwise stock junkyard Gen 6 big block, short block, because you can't put enough camshaft in it anyways. So there is no choice there for the ultimate cylinder head. And then I'm going to add boost to that. Which one of those is better under boost? It doesn't matter. Your choice isn't going to come down to that. Your choice is going to come down to which one will fit, which one has a small enough valve in this case to work with this kind of, which one has the chamber that I want, what are the prices on them, which one has a small enough combustion chamber to add the compression that I want, which one has small enough valves where they don't get overly shrouded or hit something in this case on a big block Chevy. You know, all of these things will come into play way before does one of these heads work better as a blower than the other. The one that's going to work better with a blower or a turbo is the one that's going to make more NA power. And like I said, in a lot of these cases, if you're building if you got a 454 and you have the available cam that will fit in a 454, you're talking about a sub 500 horsepower motor anyway. So if you got a sub 500 horsepower motor, or let's say that it's 550, let's say you could make 550 somehow. If you're going to make 550, almost any of those heads will support 550 horsepower. So, and they'll support 200 more than that. So the fact that one will support 211 more than that, the other one 208 more than that, doesn't matter because you're not using either one of them anyway. And then when you put a blower on them or a turbo on them, that's also going to work. So you pick the cylinder head that's going to work. It's going to do the thing that you want, that costs the amount that you want it to cost, whatever your budget is. We all obviously are on a budget. And then think about all of the things that go into the reasoning behind your build. What is my power level? What is my compression that I want? Am I running this on pump gas? Do I want lower compression rather than high compression? All of these things are way more important than whether or not your particular cylinder head that you're picking, you think that has somebody has told you that is like, oh, this works good on blowers. They all work good on blowers. Even stock cylinder heads work good with blowers. They just don't make as much power as a better head does because they don't make more power NA. And then, as we've seen in all these times doing all of this testing with the most recently with the M90 supercharger, as we go up in NA power, particularly on a supercharged application, when you add the supercharger to it, when we're spinning the blower at the same speed, if you go up in NA power, you come down in boost, you go up in airflow. So it's just nothing but good. So if you can make the NA motor more powerful, which you would with good cylinder heads, you're going in the right direction. The other thing that will happen that a lot of guys don't realize is if you lower the static compression, you're probably going to lower the boost too. a lot of guys don't realize that that's happening, and because you're having to fill a different volume. And I remember the first time we did a test on that, and I thought, wow, what's going on there? Why are we changing the boost? And I thought, oh yeah, this is why. There's more stuff in there, just like going to a bigger motor, except we lose power, we don't gain power. It's much worse. Although it may not. Maybe we're getting more airflow. So let me know what you guys think about that in the comments. We do need to have a poll here going. So the upshot of all this is that when you're picking cylinder head, pick the cylinder head like when you pick a camshaft. For the other things that are really important on the list, if you're picking heads for a turbo application, like or a blower application, like for instance, when you're getting LS heads and you want to pick them for, these are good heads for turbo or boost or whatever. You can make lots and lots of power with stock heads. The limitation ultimately becomes on factory LS heads. Like you can make 1,000 horsepower with any of the stock heads. You start running into problems with deck thickness and the head not sealing on a head gasket. That's why most guys are making a bajillion horsepower on LS stuff. They're doing with heads that have thicker decks, because a lot of the aftermarket heads have much thicker decks. The head itself is heavier too, obviously, but is more robust. The deck doesn't move around. It doesn't, unseal the head gasket, and it tends to work out better for very, very high boost stuff. But again, that's not mandatory for things that are going to be like sub 1,000 horsepower. So again, lots of other considerations beside what is the optimum head for a blower or turbo. You have a lot of other things to look at for your blower or turbo cylinder head choice. So see what you guys got going on. Start a poll. Okay, so if we do a cylinder head upgrade on a supercharged motor, by spelling, we do a cylinder head upgrade to a supercharged motor, will we change the power? Will it add power doing a cylinder head upgrade, even if we don't change the boost? Like we don't keep boost consistent. So if we've got a blower and we're running it on a motor with, let's say, stock heads, and then we do a cylinder head upgrade, and we don't change the speed of the blower, will we add power? I should have asked, are there supercharged cylinder heads? Let's see, we got there's COVID rocks. Yeah, we've got some of that going on. Turbocentra should probably be focused on wiring. I know I got a lot of stuff that I got to get done. I was supposed to go down to West Tech, but I didn't make it down. Just getting over COVID. Yeah, there's a lot of that going around. Good to see everybody. Hopefully everybody had that's not here that on the last video that I did, but hopefully you guys had a good Christmas. Having a rough December, but pull through. Hey, we're here for you. Got here late, watching on double play speed to get you up. 1990s Micro Machine Guy. That's right. Summer's almost over. Better January. Hopefully 2024 will bring good things. Got my fingers crossed. El Toyo World Machine. What transmission? This can be good on a 408, 240, 252. Yeah, is it a... Yeah, that'll work. A 358 small block Chevy, 10-to-1, aftermarket, gasket ported, screw and stud, 1.6 rockers, 480 crane setup on 106. What's the duration on the camshaft? Must be running a 300 shot. And what heads are on there and what intake is on there? And I'm curious why only are you running in a class that can't have more than 500 lift or something? Nathan, 408 stroker on 85 and a T6 85 millimeter turbo. Whatever the turbo will flow, whatever that turbo will support. I'm thinking, I don't know, 12 or 1300, depending on the 85 millimeter. James, New Zealand, what's going on? Gen 6 stock heads, massage, rocker conversion, comp 421 cam, standard pistons, single plane, E85, twin DG45s, Holly Sniper. And then you got to ruin it with thoughts. I don't know what you mean by thoughts. Recently talked to a friend who saw a blower on a big cubic Chevy that made no boost. Engine moved so much air that the blower wasn't spinning fast enough. Yeah, we've done that kind of testing on blowers where we keep slowing the blower down and down and down until I think we've gotten down to a couple of PSI. And usually what happens is you can change the boost curve and you can get it down really low in some part of the curve. Usually somewhere it will make boost either at the top or at the bottom. It will make boost and then might make very little or none in some other part also, depending on what the flow potential of the blower is relative to the airflow needs of the motor, which change obviously with efficiency and engine speed. But that's certainly possible. You can do it so that the blower is only spinning just enough to feed the motor. So we're 706, 862 is still the go-to for stock running boost. I always recommend those for a 4.8 or a 5.3, not because I think that they're superior in any way, but because you already have them. And short of upgrading to an aftermarket head or some ported head, there's nothing else that you could put on there that's going to make them better. I mean, you can make as much power. The turbo that you put on there is going to dictate ultimately how much power you can make. And then can you keep that all sealed up is really going to be the issue. How long will a pole stay 100%? We're at 97 now, so apparently not too long. Made it to 28 votes. Oh, that's good. Cheap throttle body spacer is dangerous. Throttle could suck at wide open throttle. Need a spacer for clearance, not the 20 horsepower it claimed. Yeah, 20 would seem like a lot. Part of my 3-valve Mustang heads, but people constantly say there's no point unless you're making 700. That and Boost Novice, it's an interesting conundrum there for porting those heads. So those heads flow fairly well to begin with, and it's just like with a LS head. So like if you were going to whether or not to port a LS3 head, let's say, and so you're going to put a turbo. I've got an LS3, I've got a cam in it, I've got springs, I'm going to put a turbo on it. Should I port the head? Well, not if you have 1,000 horsepower turbo on it, because that motor is easily going to do that. And it's the same thing on a 3-valve deal. A 3-valve deal has enough head flow to support more NA power than you probably could make with a 3-valve, I'm thinking. And then when you start adding boost to it, the number can get multiplied a lot. Most guys with 3-valve Mustang engines are not making as much NA power as they could, and then we start multiplying that with boost. But it just means that you're going to get to some point with a higher boost level because you just started out with a lower NA power. You can make a lot with a 3-valve Mustang, is what I'm saying, with a 3-valve motor. Richard, did you test dimple golf ball ports? Is it useful? No, Eric Weingartner tested it though. In terms of flow, I've never tested it on the dyno. Bigger ports, you lose velocity. I mean, as a general thing, I guess you could say bigger ports might lose velocity depending on what the airflow draw is underneath them. When changing to a better head from standard, the flow increases, so power goes up. Boost level will be lower if you don't change the blower speed. That's correct. So we're going to go from top chat to live chat. I just don't know what people mean when they say thoughts. It's just too open-ended of a question. I don't know. You're probably looking for something in particular that you're wanting to ask. So if you can zoom in on the thing that you're trying to ask, then I can answer it a little better. It was 6-liter stock cam and heads, Vortex supercharger, kind of unimpressive. Through a 4L80, I have a set of 799 heads to go on it. Plan to get a BTR supercharger cam. Hope it's worth the work. What I would suggest, Andrew, is not get a supercharger cam. I would suggest, unless they've made changes recently to their centrifugal supercharged cam, which in my opinion should be an NA cam. You should get a cam that adds more power in the middle part of the curve than on the top. And like a positive displacement blower cam will add power at the top, but it'll be soft down low, which is a terrible combination. Like running an LS9 camshaft with a centrifugal blower is a terrible idea, unless all you're trying to do is get rid of any potential for detonation. But put a camshaft in there that makes a lot of mid-range power, and you'll be much happier with what's going on with a centrifugal blower, because it's soft down low for boost, because it's only making 2 pounds or whatever down low, and then doesn't get to where it's making peak boost until peak RPM. Corey, port or not to port 706 heads on a boosted 5.3? Well, we need to be specific about what you're really asking. So how much power are you trying to make? What turbo do you have? And then the question becomes, can you already get there without porting the heads? More than likely, if it's 1,000 horsepower or less on the turbo, like an S475 or an S480, I wouldn't recommend porting the heads. You can do everything that turbo will do with unported heads. Is a 3-valve worth it, or go with a 4-valve? Depends on what you're trying to do. You could top out an M112 blower on a 3-valve very easily. So I would look at doing more work on the blower rather than the motor. But you take a 3-valve, you hand port the heads, put cams in it, and then do a bunch of work on porting the blower, and hopefully run an intercooler on it, and you could make power that way. You don't need to go to a 4-valve for a 112 blower. Bob, your twin GT45 thing, those turbos will support 1500 horsepower or more. So, are you adding nitrous on top of that? You're not going to be able to spray 300 horsepower on top of topping out those turbos on a stock bottom end Gen 6 motor. 408 stroker with an 85 millimeter. Nathan, it'll make whatever the 85 millimeter is. The 408 stroker doesn't matter. You could be a 5.3 and it would be the same. And in fact, depending on what the exhaust flow is, a 5.3 might actually make a little more power because it wouldn't be limited by exhaust flow. I don't know what hot side you have, but whatever the 85 millimeter will support, like I said, 12 or 1300 horsepower. What does it take to make 500 horsepower from an L28? Cam, ported head, boost. Turbocentra, the best way to get aluminum off your carbide is to not have it get on there to begin with. That means it got really hot. You got to keep, when I do porting, which I'm not an expert porter, but when I do it, I make sure to keep dipping it in transmission fluid to keep some lubrication on there so that stuff doesn't get on there. But I usually take a pick and get it off. Andrew. Oh, is that on your Vortec thing? I can't remember now. Was it an LS? Yeah. Okay. 6 liter. I would look at a Truck Norris cam or a hot rod cam for that. Bob, like I said, the turbos will support 1500 plus horsepower as long as you think your motor will stay together for that. I use oil to get it clean, to clean the carbide. Yeah, I use transmission fluid when I'm porting stuff just to keep. And what I do is once you dip it in there, I'll put it in the port and then spin it because it all wants to shoot off. But when you do that, it shoots off onto the area that you're porting, and then when you go in, you have some lubrication going on there for the bit so it doesn't load up. Ponderous, a 6 liter on for 700 wheel horsepower is a realistic amount. If you're taking the motor out, I would put ring gap in it. But cam and springs, 600 wheel horsepower is not that hard. Single turbo will easily do that. Nick, you got to talk to all the cam manufacturers for that. Daniel, they got a good scene going on in Lodi there for street cars. I was talking to Chad Reynolds today about we're trying to schedule a time to get together to do the 24-hour Super G Mega Marathon the live feed marathon. So we're going to put that together in 2024, hopefully early. And also the people from Stainless Headers reached out about the 8-into-1. And so I think we're going to be able to put something together with those guys too, which will be very cool. So thanks to those guys for reaching out. Looking at a 351 Windsor cam heads intake prices with carb legal AFR or trick flow heads. It'd be cheaper to get a 5.3 if you're doing the work. Yeah, that's one of the, certainly with the 5-liter or 351, because it's limited by cylinder head flow too. The swap stuff, because, you know, we've talked about this before, where you can go get a 5.3 or whatever from the wrecking yard, and that's cheap. But the whole swap thing is not as cheap as people like to make it seem. But to be able to make the power that even a stock 5.3 has, you'd have to have a lot done to either a 5-liter Ford or even a 351 Ford. You'd have to have heads and cam and intake manifold for it to get up where even a stock 5.3 was, but let alone a cammed one. New Year's Day streetcar race kingdom drags at the old airport. Okay, cool. What converter do you recommend for 600 to 700 horsepower range? This is on a 6-liter, you can get away with something that's fairly small, but most guys probably would be in the 25 to 2800 range. Nathan, the 408 is going to affect the response rate of the turbo. So it might be that the turbo would be more responsive on the bigger motor. And if it is more responsive, and then you're going to make more torque in whatever range that is. I don't know where it's important for you to be making torque. Obviously not at 600 RPM, not at 1,000, probably not at 1,500, but somewhere after that, let's say somewhere after 2,000, probably more than that if it's an automatic. But it might be with that turbo size, you know, on an 85 millimeter on a 4.8 would certainly be soft down low. So a 408 would be much more responsive. The issue with the OBD1 Ford is the E4 systems. The LS computers are infinitely better. We made a lot of power. I had my A9L stuff, and especially now, and this was before you could even tune it. Now that you can tune an A9L on a mass air car, I've never had any problems with mine. I don't know what that 421 cam is. But on E85, you should be able to make way over 1,000 horsepower on the big block with 2 GT45s on there. Probably a good bit over that and still be safe. Can you catch me up really quick? Can we go back and cover everything that we've covered for the last half hour? The 2.2 needs to go S10. The 2.2 needs to go back up on the dyno and needs to have, like, I have 1,000 tests set up for that thing. So we just need to get it running and working right, and that will happen in early 2024. What do you think of this cam 206 at 50? Is it a single pattern cam, Andy? And then what are you using it for? It's a dedicated turbo cam for a 2.2 or a 2.3 liter Ford. It's not really a dedicated turbo cam. It's just a cam for a 2.3. Somebody sells it maybe as a turbo cam. I would pick the cam not based on the fact that you have a turbo 2.3 or an NA 2.3. I would just pick the cam based on what do you want the camshaft to do? Like, what are you trying to do with the motor? How do you want it to idle? How do you want it to, you know, are you using it with a stock converter? All of these questions that we always go over. And a 206 cam wouldn't be a camshaft that I would pick if I wanted to make and I wanted to rev this thing and wanted to make power, I wouldn't pick a single pattern cam. I normally don't pick single pattern cams for almost anything, but a 206 cam would be fine for a turbo 2.3. It should be fairly responsive. It's going to be limiting in RPM, like I talked about. What's up? What's up with the poll question? Right now we're at 97%, which is still pretty good. Will a cylinder head upgrade add power to a supercharged motor without changing the blower speed? So if we don't speed the blower back up to make the same boost, and we just do a cylinder head upgrade, will it make more power? What software to tune an A9L? I think way back they were using the what the hell's the name of it? Whatever Mike Wesley stuff had way back in the day. I don't remember what the name of it was. Corey, the turbo will make the power I'm looking for. If I could make the same power with ported heads, would it be easier to tune having less boost? I don't know if easier to tune. You're telling it you want this amount of fuel sprayed in that will ultimately result in 11 to 1 or 11.5 to 1, whatever it is you're running under boost. That's easy. That's not hard. The tuning window would become wider, meaning you could miss by a degree of timing or so. If the boost is lower and the temperature is lower, it puts more stress on your intercooling and stuff. So if you port the heads, you can make the same power at a lower boost level, which is beneficial. But it's not mandatory for you making that power. Can't wait till people start building the new Iron Coyote blocks. Up to 5.4. Are the sleeves bigger on the whatever these blocks are? If I don't 5.3 swap it, I'll most likely MAF swap it, and then a mild cam. It's got ported E7s on it right now. Is that no brakes? Is that a 351 that's in there? Because you can make decent power with a 351. yeah, Eric. It'll never be 100%. One person will always ruin it because they think that that's funny, you know. Have 317s on a turbo 6-liter with 706 or any head be superior? Not again. The question that isn't the question. We at any given boost level, a 706 head will make more power because it has higher compression. But that's not the question. The question is how much power do you want to make, and can you make it with those 317 heads? The answer is yes. Well, it might be yes, depending on what size turbo you have and what power output you want. Lower the pressure, which lowers the heat, which equates to more horsepower. Maybe not. If you have an intercooler and you run 20 pounds through an intercooler and you run 21 pounds through an intercooler, the resulting heat exiting the intercooler might not change that much. Would a 6-liter with LS3 heads and intake make 400 horsepower at the tire with a hot rod cam? Probably so. A 6-liter with LS3 heads and almost any kind of camshaft is going to be more than 500 at the flywheel. The only way I can see a better flowing head lose power would be if you gain 10% flow, but the combustion chamber goes from 55 to 90. That would be huge. A 317 head does flow more than a 706 head, but it makes a lot less power for a number of arguable reasons. The Coyote iron blocks have enough meat to get sleeves up to 3,700, I believe, but I need to verify the most recent spec sheets. I just wonder how much head gasket sealing you have between that bore size. I have an M70 BMW motor. What sounds like a good twin turbo setup for 800 horsepower? Well, 800 would be right in the realm of GT3076s or GT3582s. So Crash, you're creating your own scenarios now for the poll question. I like the idea of a budget 393 with EO heads around 4,500 if I assemble it and build a cheap exhaust. Yeah, I obviously would choose a 351 over a 302 if you can fit both of them in the area that they're going in. It's a much better combination. I always wanted a 351 in my Mustang. Now an aluminum 5.3 would be way better. Just bought a hybrid Escalade 6-liter drivetrain. Did you guys see a video going around? Ellis heads on 351. Yeah, that's been around for years and years and years. Eric, I think I will be on tonight. And actually, the thumbnail that I have up is a big block, so it's a 496 with the 871 on it. And the reason, well, I did a lot of testing with that particular motor. It's a really good motor, but we did a bunch of testing, and the one that we did in the photo that I have up, we compared 315 heads to 335 airflow research heads. The 335 heads obviously flow more than the 315 head does, but they didn't make any more power. They didn't make any more power NA, and they didn't make any more power when we ran boost. So that's the other scenario that guys get. And the reason why I was kind of asking the question I was asking in the poll, it's hard to get it because you're limited in the number of characters that you can do. But you'll get guys that say, oh, but yeah, it didn't make any more power NA, but once you add boost, it will. Actually, no. In fact, it'd be more of a reason for it not to make more power. The only possible scenario there is, again, do you have enough blower? And in an 871, we don't for that instance. But do you have enough blower or turbo where you could ultimately get the smaller head, in this case, the 315 versus a 335? Could you get to the point where you're trying to flow enough air where you make the littler head restrictive finally? Not in the range that we were running at. Actually, we were running at about 1,000 horsepower or something. And so in that range, the 315 head is like, I can almost do that NA. so we're not anywhere near what kind of flow rate we would have to be at to make me restrictive, especially under boost. It raises that number way up. So we never got there. And ultimately the 335 head compared to a 315 head on the Airflow Research big block side, the 335 head could support more power. But two things were happening. One, we weren't anywhere near the power levels where that would happen. And also, we weren't anywhere near the lift ranges where that would happen also. Because most of the gains of a 335 over a 315 head, and you'll see this on a lot of different cylinder heads, is the gains that you get in airflow where the bigger, better head starts flowing more is at higher lift ranges. So we see that with the 799 head or 317 head versus a 706 head. The gains that you get in airflow, the majority of the gains are at higher lift ranges. And so on the Airflow Research head on this big block, we would have had to go to, beyond 650 lift. We'd had to go to 700 or 750 or even 800 lift, where the bigger head could really say, hey, look, I'm flowing a lot more out here. I'm not doing it in the 600 lift range or in the mid 600 lift range. There's really not a big advantage there anyway between the heads. All you have is I just have more port volume and not a lot. A 315 versus a 335, relatively speaking, as a percentage, isn't a huge change. So you're not going to get, oh, there's so much less airspeed or, all of the other things that people would want to argue about. So we weren't taking advantage of it because of the power level that we were at, or because of the lift range that we were at for the camshaft. So in that particular head test, we had all but dictated the outcome based on based on our test procedures, basically. What supporting mods you recommend for a turbo 6-liter? You just need heads and cam, and I always put MLS head gaskets on it. Probably has that already from the factory, but I put ARP head studs on it, and I put ring gap in it. Turbo 5.3 with a ZF 8-speed auto would be a good combination. Yeah. More importantly, how much power do you need to get 3,700 pounds to 150 miles an hour in the quarter? Well, you can go to Wallace Racing calculator and you can get the power numbers. But when you do these calculators, you have to understand that that is an ideal situation, which nobody has, unless you're a stock eliminator guy, where you're making the number that they suggest because everything else is perfect with their combination, and you're utilizing every last like ounce of power that you're making from that motor. Most guys are not doing that. So you normally need more power than they're suggesting, but it gives you an idea. So go to wallaceracing.com and you can use the calculators for that. Oil seems to work. Yeah, oil is fine. Anything that helps with that is fine. Transmission fluid or power steering fluid or oil, all of that's good. Is the 220 at 50 cam too big for a real world? No, probably not. Again, the thing with camshafts, and I get this question all the time. I got it a couple of times today. The camshaft drivability question, that's what this guy was asking, is when is a cam not drivable? That's wholly subjective. Like the amount of nonsense that you're willing to put up with is just subjective. You cannot make a 220 or 230 or 240 camshaft do the things that a stock camshaft does. No amount of tuning is going to make that thing do what the stock camshaft does. It won't do that. So as you go transition from a stock camshaft toward that camshaft, everything else that you have starts getting progressively, for lack of a better term, less drivable. A 230 cam or a 240 cam, guys still drive it around. So it's not like the car will stall every time you try to drive it, or you have to keep revving it or the plugs load up or anything like that. That doesn't happen. Again, it all depends on what you're willing to put up with. Does the thing have to idle higher? Does it want to overheat? Does it want to stall when you're going through drive-throughs? Is it loud? All of these things are totally up to you in terms of what you'll accept for drivability, because drivability is, like I said, is a wholly subjective thing. I recently read the 32 valve 928 Porsche heads have the same bore spacing as a 440, and there's the dude that actually got 4 heads to work on a 440. I've not confirmed this. They the guys from what's his name? Pete Ardema put 928 heads on a big block Chevy. Which motor would be better to add boost to? One with a high flow, high compression, or one with compromised flow and low compression? I don't know what you mean by better. You have to tell me what your definition of that is. If you're talking about power, high flow heads with high compression and the right camshaft will make more power than one with lower compression. But that assumes that you have the octane, and this is going to be a race kind of application that assumes other things. But as an absolute, higher compression and flow and bigger camshaft, that makes more power. It makes more power NA, and it's going to make more power under boost. But that doesn't necessarily mean that that's a better combination for a guy that's driving on the street and has limited octane. So there's no universal best there. Any word on the Dimple piston coming through at all? They want to test it, and they've already asked me to, but that's the only word that I have. Tim, you're working on an old one? Why are heads measured in cubic feet per minute and turbos measured in pounds per minute? Is it because turbos change air density so cubic feet becomes inappropriate? I honestly don't know the answer to that. I'm thinking that the turbos, are they taking into account mass flow then, and they're not on a cylinder head? I'm happy with old 241s on the LS1. Y7 maxed out current first. Love boost, but one step at a time. This is a great thing, testing different scenarios. Yeah, the 241 heads work good. I tested those when we tested all the factory heads. Yeah, Ryan, we covered that, a lot of that stuff. Thicker heads, change in combustion chamber size, and you know. Is there a site with all variations of the LS? What do you mean, all the factory ones? If you're looking for all the factory ones, then yes, on Google, on all cylinders up at Summit, they have a listing of all of the factory LS motors. The difference between an LQ4 and LQ9, yeah, it's camshaft and compression. And probably, and they don't go into this because I don't know how they would, but tune, and the difference between an LM7 and an LQ9 would be dramatically different because you have a change in displacement. They're a different block. They're a different bore size. They're the same stroke. They are different cylinder heads. They're different camshaft, except for an LQ9 would be a different camshaft, different cylinder head, different intake. Although the LQ9 may have come with early ones may have come with a truck. Our poll is still at 94%. That's still pretty high. Which is a better head for high torque, high horsepower? You don't get to get both of those. You're not going to have to worry about cylinder head. You can make, with a stock cylinder head, you can make all of the power with those turbos. Are you familiar with Comp Cam's retrofit roller lifters for small block Fords? We have used them. I try to just get a roller block. It makes life easier, but we have used link bar lifters for that. 220 cam is good as long as you're towing your boat really fast. A 220 cam, if I was putting it in for a driver, I would probably make it a single pattern cam. It would be more drivable as a single pattern cam and as a 6-liter and not a 5.3. Lazy Hound, when you talk about cam moving the power band, how big is the spread? Not as much as most people think. But yeah, you can't have a 1500 to 7000. The motor will rev from 1500 to 7000, and it will make power from 1500 to 7000, but it's not going to make all the power at 1500 and all the power at 7000 and then all the power everywhere in between. $1,350 horsepower, 8.5 second, quarter mile, 169. That's a lot. Ryan, the Tornado throttle body spacer definitely adds 20 horsepower. To what? I'm scrolling back. I'm trying to look at your previous comment. So I'm all in on the Tornado. I saw a dynograph the other day and it was a perfectly straight line. The guy said it was because they take RPM from the ECU and not from the roller. You mean the power curve was perfectly flat? Like it made the same power at every RPM? Junior, thank you very much. I have an LS2. I'm doing a 402 stroker with LS3 heads and LS3 style intake manifold, YSI V7 blower. Okay, so a YSI blower is like 1,000 plus horsepower blower. So you can make a lot of power with that. I have videos up of that, of what you're talking about. In fact, exactly what you're talking about. We did an LS2 stroker hybrid because we put the LS3 heads on it. I can't remember what intake we ran on there. It might have been an LS3 intake manifold. A good sized cam in it, and we ran a I might have even been a YSI on it. It might have been a Mondo blower also, but we made more than 1,000 horsepower with that. Power curve was angled up, but the line was perfectly straight. Yeah, that's just a function of their data logging and its calculation. We see that too. I get guys telling me, "Hey, look, the horsepower and torque curves didn't cross at 52.52," and I'm like, "Well, they have to. They don't have a choice on whether or not that happens. This guy's combination wasn't special in any way, and it's just because the X and the Y axis are not, the horsepower and torque readings are not using the same axis, so they're not scaled. What is it called? They're not force scaled. So they're not both using the same scale. You'll see the numbers are different on the torque number versus the horsepower number. But if you're using them both on the same scale, they will always cross at 52.52. You did two identical motors, big bang, with only difference being one has a lower valley girdle. What motor are you talking about? Are you talking about a Ford? Dual tornadoes would probably make a boost. That's right. But one on top of the other, compound tornadoes. Junior, you don't have to give me money. Just ask your question. TSP custom grind LSA cam, also TSP 660 springs, valve job. My question would be, what injector size? Oh, so your injector size is just based on your intended power output. How much power are you wanting to make, and what fuel are you going to run? If you're going to run gas, you could get away with probably an 80-pound injector. But if you're running E85, you're going to have something quite a bit bigger than that, 25 or 30% bigger than that. So a lot of guys would run a 1,200 or 1,500 cc injector for something like that if they're running E85. Have you ever tested the Comp 4 pattern cams? Yes, I haven't specifically, but the guys, Steve at West Tech has run those. And the thought behind that was, let's change the camshaft in individual cylinders, inners and outer cylinders, to try to offset what's happening with the intake runner. So you got, normally on a single plane manifold, which is what they're doing this for, you have 4 short runners in the middle because they're close to the carburetor and the cylinder head. And then the longer outer runners are longer. Those ports are farther away from where they want to have the central carbureted opening be. And so they're trying to skew that with cam timing. And what they found is that you can't really do that. You can't really change the intake manifold with the camshaft. You can change the onset of the reflected wave, but it still doesn't fix everything. The intake manifolds are still going to do what intake manifolds do. You are still going to have variations in air fuel distribution in the manifold inherent in the design. It's not cured by the camshaft. Do I need to round the inside of my plenum where my throttle is bolted? It's a homemade intake manifold. You mean the backside of it, to taper the opening of the backside? Junior, 1,000 to the tires. You're going to have to spin that blower all the way up to do that. But, and if are you running E85? Probably not going to do that on gas, on pump gas. Yes, Happy New Year's to everyone. I probably will be back on maybe tomorrow. Oh, tomorrow's New Year's Eve, huh? Have you considered doing a YouTube membership program? Yeah, I want to do a what is it called? Not a membership, although that's what I think that they're calling it now. E4 spark plugs. Is that one better than an E3? Yeah, Boost Novice. I don't know about the Valley Girdle. I don't think I've ever tried one of those. I don't know that a Valley Girdle is going to stop the cracking up from the. I don't know how much that would help. I don't know if that's going to stop that crack that runs up from the cam tunnel. I know Buick guys do girdles. I don't think that the main girdle is going to help on a 5-liter Mustang. Maybe the Valley girdle would. Don't think the main girdle is not where they get hurt. One more minute. We're going to close out our poll at 94%. Cylinder head upgrade, add power to a supercharged motor without changing the blower speed. And again, it would depend on what heads are we talking about. A head upgrade, if we went from, say, stock LS3 heads to ported LS3 heads, would we really get any change in power? We might get a little bit, because we did see a little bit NA when we did that test, even with a stock camshaft in it. So we might see something there. I've heard block plates help hold the pushrod 5.0s together. What's a block plate? Like a for the motor mount, you mean? 6% trolls, that's right. That would be interesting if that's a good point, that a motor plate. So they use that to mount the motor, common in boats and stuff, but also in drag race cars. Interesting if that would help, because you'd think that if you solidly mount the block and we have distortion in the block, that might want to pull the block apart. I don't know. You'd think that having it go all the way across the front would be good. And on that note, it is time to go. Thank you guys all for showing up. I'll try to be back tonight. Pew, pew, pew.